Hello everyone, welcome to Ru's tutorial. So today we will discuss coordination compound. So take one question. The given complex is FeCN6 3 minus, and in the given complex we have to find the hybridization, shape, magnetic property, number of unpaired electrons, spin only magnetic moment, inner orbital, outer orbital, high spin, low spin. In exam, any 3 to 4 topics are given of 3 or 4 marks. So let us discuss. So first we will find the hybridization. So how to find the hybridization? For this, first write the electronic configuration of the metal given in the complex. So let us take the first example. First is given as iron CN6 3 minus. So metal is iron Fe. So write its electronic configuration. So for iron the atomic number is 26. So how we can write the 26? So it can be written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d6. That is 26. So instead of writing this long electronic configuration, we can take the help of a noble gas. So before iron, as we know, argon is the noble gas which have the atomic number 18. So instead of 1s2, 2s2, 2p6, 3s2, 3p6, this 18 electron we can write directly argon, and after that what is left? 4s2 and 3d6. This is the first step. Now second, find the oxidation number, means charge of iron here. So what will be the charge of iron? So let us take the charge of iron be x. Then Cn. What is the charge of Cn? So as we know that Cn negative is there. So one Cn have the charge -1. How many Cn are there? 6. So -1 into 6 equal to, we are writing overall charge. Overall charge is -3. Now solve it. So it will be x minus 6 is -3. So x can be written as -3 plus 6, that is +3. Therefore oxidation number, that is charge of iron, is 3 plus. So our next step is write the configuration using the charge. So iron 3 plus. So meaning of 3 plus is 3 electrons are less. So how we can deduct 3 electron? So first 4s will lose electron, and after that 3d. So we have to remove 3 electrons. So 2 will be removed from 4s. Why? Because it is the outermost shell, and 1 will be removed from 3d. So iron 3 plus will be argon and 3d 5. Now after this, write the orbital notation. So 3d, d have 5 orbitals, so make 5 box. So this is 3d. How many electrons are there? 5. So 5 electron, how to fill up? So it is fill up 1, 1, 1, and when all will be completed, then pairing of electron will start. So as we have only 5 electrons and all electrons are filled in the orbitals, so no pairing will be there because we have only 5. After 3d, we have to write 4s and 4p. So this is 4s and 4p in every question for finding the hybridization for the element from 21 to 30 atomic number. So now 4s and 4p is not there. So this boxes means orbital will remain empty. After this, we will write the complex. So complex is FeCN6 3 minus. Now see in the complex what is ligand. So ligand is Cn. Cn means cyanide, and here which one is electron donor? Carbon. So carbon is donor atom. So in 3D metal, if carbon and nitrogen are donor atom, then that ligand are considered as strong field ligand. For carbon donor and nitrogen donor, we call it as strong field ligand. If strong field ligand is there, then pairing of electron will take place. So here Cn is ligand which is strong, so pairing of electron will take place. Means this electron will be paired and this electron will be paired. So after writing the complex, we can pair up the electrons. So this 5 electron in 3D will looks like this one, 2 to 1, and these two orbital will be empty or vacant. So how many ligands have donor atom? So one Cn have one donor, so total 6 Cn are there. So in the given question total 6 donor atoms are there. So number of donor atoms should be equal to number of empty orbital. So these two orbitals are empty and 4 are already empty orbitals. So total number of empty orbital becomes 6, and we have coordination number also 6. So 6 donor atom will donate their electron in the vacant orbitals of the metal. So write these 6 orbitals together. So after writing these 6 orbitals together, why? Because during hybridization, all orbital intermix and rearrange to form similar types of orbital. So in these orbitals of metal, ligand will donate their electron pair. So here 6 electron pair from 6 Cn minus ligand. So what will be the hybridization? So write the name of the boxes or orbitals. So first box are coming from D, second is also coming from D. So there are two D orbital, first and second. After that this is coming from S, and after that the last 3 are from 4p. So last 3 are from P. So first two orbitals which are involved in the hybridization are from D. So D2, next is P, and next 3 is from P. So D2sp3 hybridization will be the answer. So first our answer is done, D2sp3. Now next is magnetic property. So for magnetic property, if unpaired electrons is present, then they will be paramagnetic, means attracted by magnetic field. If all the electrons are paired, then they will be dimagnetic, means repelled by magnetic field. So here we are seeing that one unpaired electron is there. So due to the presence of this unpaired electron, magnetic property will be paramagnetic. So paramagnetic will be the magnetic property due to presence of unpaired electron. There are one unpaired electron. Shape. So either hybridization is D2sp3 or sp3d2. The shape will be octahedral. Next, so we can write that the shape is octahedral. So octahedral will be the shape. After that, number of unpaired electrons. So unpaired electron is denoted by N as written here. N is the number of unpaired electron. So we can write that number of unpaired electron is how much? That is N is 1. So N is the number of unpaired electron. So unpaired electron is 1. Then spin only magnetic moment. Spin only magnetic moment denoted by mu, and which can be calculated by the formula root over n of n plus 2, and unit will be Bm. Bm is the Bohr magneton. So let us find the magnetic moment. So magnetic moment will be, so we have the formula mu is equal to root over n of n plus 2 So value of n is 1 because one unpaired electron is there. So 1 into 1 plus 2, that is equal to root 3, and root 3 is 1.73 bm Bohr magneton. After that, high spin or low spin. So if the number of unpaired electrons are more number of unpaired electrons, then high spin. If unpaired electron are less, then low spin. So here unpaired electron become less. Initially they were 5, but due to strong field ligand, electrons are paired and unpaired become just 1. So due to less number of unpaired electron, it will be low spin complex. So it will be low spin complex. And after that, outer orbital or inner orbital. So see, during hybridization, inner 3D are used. So if the inner 3D orbital are used, then the hybridization for inner 3D is D2sp3, and it will be inner orbital complex. The inner orbital complex because of D2sp3, where D is the 3D. If 4D, outer D is used, then it will be outer orbital complex. So this is the answer for the first question, FeCN6 3-. Now let us proceed to the second one. So first we will write the electronic configuration of iron. So again, iron is 26, so we can write in short form argon 18, then 4s2 20 and 3d6, as we have written in the first question. Then find the charge of iron. So same, iron have the charge x. Next is fluorine. So halogen have the charge -1. So F minus, Cl minus, Br minus, I minus. So fluorine have the charge -1. How many times? 6. And is equal to overall charge -3. So after solving, we will get x equal to +3, as we have done in the first question. So we can write the iron 3 plus. So what will be iron 3 plus? So we have to decrease 3 electron. So first we will deduct the electron from 4s, and after that 3d. So iron 3 plus will be argon, then 3d5. So after writing the electronic configuration, we will write the electrons in the orbital. So make the orbital, this is argon, and 3d. As we know, d have 5 orbital. So these 5 orbitals will be filled up by electrons, and we will fill up 1 by Hund's rule. So this is 3d, and after that 4s and 4p will be there, but the orbitals will be vacant because we have no electrons. Now after that we will write the complex. So complex is FeF6 3-. So in the given complex, see the ligand. As we have done in previous question, ligand was Cn minus, cyanide. So their donor atom was carbon, which was strong. But in this case, the donor atom is halogen. Fluorine, fluorine, chlorine, bromine, iodine, these all are halogen, and we know that halogen are weak field ligand. And if it is weak field ligand, then no pairing will be there, because weak field ligand will no pair the electron. So electron will remain the same because we cannot pair it up due to the weak field ligand. So we have total 6 donor atom from 6 fluoride ion. So we must have 6 vacant orbital. But as of now we have only 4. So from 2, how we can fill up this 6 electron pair from 6 ligand fluoride minus to the 4 orbital? We cannot fill it up. We required 6. So in this case, we will take the help of 4d orbitals. We will take the help of this 4d, outer d orbital, because we require 6 vacant orbital, but we have only 4. In the first question, due to pairing, two orbital become empty, but in this question we cannot pair up. So take 6 orbital together, because during hybridization all orbitals have similar energy, and 1 2 3 4 5 6, this 3 orbital will remain vacant. This is 4d. So this 6 orbital will have 2 electrons of the ligand. So 6 electron pair from 6f minus ligand. So what will be the hybridization? So write the name of the orbital. First orbital have the name S, then remaining 3 are P, and last 2 are from D. So sp3d2 hybridization will be there. So we have found that the hybridization is sp3d2. Now next is magnetic property. So what will be the magnetic property? So here 5 unpaired electrons are present. So unpaired electron are there. So unpaired means paramagnetic. So it will also be paramagnetic due to unpaired electron. Shape, so either D2sp3 or sp3d2, shape will be octahedral. So we can say that the shape is octahedral. So octahedral is the shape. Number of unpaired electrons. So number of unpaired electrons denoted by n is equal to 5. So there are 5 unpaired electrons, and then spin only magnetic moment denoted by mu have the formula root over n of n plus 2. So value of n is 5. So put the value 5. So 5 of 5 plus 2, that is 5 plus 2, 7 5s are 35. So as we know 36 have the root 6. So 35 will be less than 6. So less than 6 means 5.9 bm Bohr magneton. Then high spin or low spin. So see, the number of unpaired electron are large in number, that is 5. So large number of unpaired electron. So it will be high spin complex. So high spin complex. And inner or outer. So in the previous question inner 3D are used, so inner orbital, but in this question outer D are used, 4D. So outer D is used, so it will be outer orbital complex. So it is outer orbital complex. So in this way we will find the hybridization magnetic property, spin only magnetic moment, and high spin or low spin. Thank you.